Welcome to this presentation about errors in measurement accuracy. In this lecture, we will be exploring the concept of the true value and how it is affected by errors associated with measurements. We will discuss various types of errors such as absolute error, mean absolute error, relative error, and percentage error. Additionally, we will explore how systematic errors can further impact accuracy. Let's begin. Measurement and quality assurance require accuracy and precision. Accuracy is the closeness of a measured value to the true value of the quantity being measured, while precision is the repeatability of the measurement. Both are essential for creating reliable results and guarantee quality. Generally, the more accurate and precise the measurement, the more dependable it becomes. Measuring physical quantities accurately and precisely is of the utmost importance. Accuracy is the degree by which the measured value differs from the actual value of the physical quantity, while precision is the ability of the measuring instrument to reproduce the same value multiple times. Achieving accuracy and precision requires proper use of the measuring instruments, correct methods of measurement, and awareness of the limitations of the measuring instrument. Accuracy and precision are essential when taking measurements. Accuracy is the closeness of the measured value to the true value of the physical quantity being measured, while precision is the resolution or limit of the measurement, or how many meaningful digits it can have. To have reliable results, both accuracy and precision must be taken into consideration. The true value of a physical quantity is the arithmetic mean of all readings, obtained by adding together all the readings and dividing the sum by the total number of readings. In other words, if A1, A2, A3, and are the readings, then the true value is the average of these readings. Absolute error indicates the level of inaccuracy of a measured value in comparison to its true value. It is computed by subtracting the true value from the measured value and is expressed as a positive number. For instance, if the weight of an object was measured to be 150 grams, but its true weight is actually 175 grams, then the absolute error would be 25 grams. In this way, the absolute error can give us a sign of the precision of a measured value when compared to its true value. Mean absolute error is a vital metric to assess accuracy in measurement. It refers to the average of all absolute errors present in an array of measurements. This metric is frequently employed to summarize the exactness of a calculation or instrument. By computing the mean absolute error of a set of measurements, one can determine how close the measurements are to the correct value. Error will always be positive due to the absolute value of error being non-negative. The mean absolute error of a physical quantity can be used to calculate its relative error. This is done by dividing the mean absolute error by the mean value of the quantity measured, resulting in a pure number that does not have any associated units. This measure of accuracy is expressed as a percentage. Knowing the relative error helps us understand the reliability of our results when we take physical measurements. Percentage error is a metric that measures the difference between expected and actual results, expressed as a fraction of the expected value. A lower percentage error implies a more accurate result, while a higher percentage error suggests that the results were inaccurate. As the percentage error increases, accuracy decreases. Systematic errors are caused by factors which occur in the system used to measure a result, resulting in inaccurate results. Common sources of systematic errors are biases, inadequate instrument precision and incorrect calibration. In order to ensure accurate results, it is important to identify sources of systematic errors and take steps to reduce them. When it comes to measurements, accuracy and precision are essential to obtain a result as close as possible to the true value. The occurrence of an error is when the measured value does not coincide with the true value, which is the reference of the precision. Error is represented by the difference between the measured value and the true value. In other words, error is the amount of uncertainty present in the measurement of a physical quantity. Errors can be categorized into two main types: systematic and random. Systematic errors are repeatable in nature while random errors are unique to every measurement. Least count error is caused by the limitation of the instrument used in measuring. Imperfections in experiments, techniques and procedures can also contribute to errors. Instrumental and personal errors can also affect the accuracy of measurements. Knowing the common errors can help in obtaining more accurate results. Errors that occur due to a fixed cause and follow a regular pattern are known as systematic errors. These errors can be divided into two categories: instrumental errors and personal errors. Instrumental errors are caused by the imperfect design or calibration of the measuring instrument, leading to an incorrect reading. Personal errors, on the other hand, are errors arising from limitations of human senses, judgment, carelessness, and response. Measurement inaccuracies can originate from various sources, such as imperfections in the experimental technique or procedure, and random errors. An example of the former is when a thermometer is placed under the armpit to measure body temperature, which invariably yields a lower value than the actual temperature. Random errors, on the other hand, result from unpredictable changes in environmental conditions like temperature and pressure, or from limitations of the measurement instruments. The concept of least count errors is being discussed in this slide. Least count is the smallest value that can be measured by the measuring instrument. A vernier caliper has a least count of 0.01 cm while a spherometer has a least count of 0.001 cm. These errors are linked to the resolution of the instruments. Having knowledge of least count errors is necessary to improve the accuracy of measurements. To reduce the least count error, using an instrument of higher precision and accuracy is one way. Additionally, the technique for the experiment can be improved. To get more accurate results, repeating the observations several times and then taking the arithmetic mean of the values obtained is important. The mean value would be very close to the true value of the measured quantity. Error calculations are utilized extensively in engineering and multiple other areas to accurately measure how close a measured value is to the actual or true value. The most probable value includes all of the data, whereas mean absolute error and relative error offer further details on the mistake. To find the mean absolute error, the following formula should be computed. 1 n array summation t equals 1 n I, a mean. This arithmetic takes into account the difference between every single measured value and the average. To locate the relative error, the formula relative error equals a mean, a mean by 100% is used. Additionally, percentage error is found by the equation percentage error equals a mean, a mean by 100%. All of these error computations enable us to determine the precision of our values. The object measured had a side length of 3.52 centimeters. Using a vernier calipers with a least count of 0.01 centimeters, our measurement led to a percentage error of 0.28%. The relative error was calculated by using the formula, percent error equals delta y, or the least count, divided by y, or the side length, multiplied by 100. Therefore, it resulted that 0.01 divided by 3.52 times 100 gave us 0.28%. The side of the cube is measured to be 20.44 plus or minus 0.02 centimeters. To find the percent change in the measurement, the least count needs to be identified first, which in this case is 0.02 centimeters. The percent error can then be calculated to be 0.098%, and the percentage change can be calculated to be 0.098%. Answer. The magnitude of the difference between the mean value and each individual value is called absolute error. This is the difference between two numbers that can be either positive or negative, and is usually expressed as the absolute value. As an example, if the mean is 8 and one individual value is 5, then the absolute error would be 3. There can be a combination of errors in any system, consisting of systematic and random errors. Systematic errors are those that occur in every measurement and require correction to acquire more accurate results. As for random errors, they act differently on each measurement and should be averaged. The total error of each measurement is the addition of both the systematic and random errors. Error due to addition can be expressed as the combination of errors, namely delta A and delta B. Delta Z is equal to the sum of delta A and delta B, resulting in the maximum possible error. When two measured values are used in calculation of a single value, the maximum possible error is the sum of the errors for both values. This can be expressed as Z plus or minus delta Z, which equals delta A plus delta B. Therefore, when errors due to subtraction occur, the maximum possible error is the sum of the errors for A and B. When it comes to addition and subtraction, the absolute error stays the same regardless of the calculation. But the percentage error that is more allowable grows with subtraction. That implies subtraction is more vulnerable to mistakes when it comes to precision. Consequently, we should make an effort to guarantee accuracy when doing subtraction operations, particularly when it is connected to scientific measurements. Understanding errors due to multiplication is of utmost importance. When multiplying two or more values, the percentage error of the total will be the addition of each individual percentage error. It is essential to correctly calculate all errors due to multiplication in any calculation to guarantee the accuracy and precision of the result. The maximum relative error in a division operation is typically calculated as the difference between the true value and the result obtained from the division. For instance, if the true value of a number is 10 and the result from division is 5, the maximum relative error in the division is 50%. This error is the difference between the true value and the result of the division, expressed as a percentage which can then be used to make adjustments in the results from the division. The most basic form of mathematical operation is addition and subtraction, however their accuracy is limited to the least accurate term. Multiplication and division however can provide a more accurate answer, so the correct answer is both A and B.